for this next example, your first step is you're going to have to factor the denominator. So this integral, I'll write it as the integral of x plus 5 over, let's see, this factors into x plus 2 times x minus 1. Now I'm going to take that single fraction and split it up into two fractions where I can then do the integral of each of the individual fractions. I'm going to show you some shortcuts on this problem, and in fact I'm going to write this, the algebra part of this problem. I need to write x plus 5 over x plus 2 times x minus 1. And I need to write it equal to some number over x plus 2 plus another number over x minus 1. Now here's a way you can proceed with this problem. That is a little bit shorter than what I did in the last problem. I'm looking at this and I have the equal sign, so it's an equation. So what I can do is take this equation and multiply it by the whole thing by x plus 2 times x minus 1. I can multiply it by the least common denominator and kind of get rid of the fraction part of it. So that's what I'm going to do. Multiply both sides by x plus 2 times x minus 1. Now I do tend to show a lot of steps here. Some of the steps I'm going to write, you're going to be very comfortable not writing these steps. And I'll do it for at least one problem here, and this is it. So I have x plus 5 over x plus 2 times x minus 1 times x plus 2 times x minus 1 equals the right side times that. Now the right side times that, really both fractions get multiplied by x plus 2 times x minus 1. So a over x plus 2 times x plus 2 times x minus 1 plus b over x minus 1 times x plus 2 times x minus 1. What happens, a lot of stuff cancels. It cleans up real nice. Here, x plus 2 cancels x minus 1. On this part, x plus 2 cancels. And on the last part, I'll have x minus 1 cancels. And you simplify this, you'll end up with x plus 5 equals a times x minus 1 plus b times x plus 2. You could do what I did on the last problem, which was multiply out like terms, get them together, equate coefficients. But there's something else you can do that may be a little bit quicker, and it's this. Let's pick a value for x, like let's pick x equal to 1. So let x equal 1. What is that going to do in this problem? It's going to get rid of this. So I'll have this. 1 plus 5 equals a times 1 minus 1 plus b times 1 plus 2. So 6 equals, this would be 0, b times 3. 6 equals 3b, and so b equals 2. Now, you could, now that you know what b is, you could plug it in, but we could also use this same technique to find a. What could I pick for x so that I find a real easy? let x equal -2. And then that's going to be -2 plus 5 equals a times -2 minus 1 plus b times -2 plus 2. So that's going to wipe out this expression where I have the b, and I'll get -2 plus 5, that's 3. 3 equals a times -3, so a equals -1. So you can use that technique sometimes for finding the numbers that go in the top of the fraction. I'm going to go back to the original problem, which was this. You can't see that. Let me move this. Okay, so here's the original problem. And here's my algebra part, the start of it. So now I have this. The integral of x plus 5 over x plus 2 times x minus 1 dx equals the integral a over x plus 2, a is -1, over x plus 2, plus b was 2, so 2 over x minus 1 dx, and that's just two separate integrals. Sometimes you might want to write them, the two separate integrals. Sometimes you'll just be comfortable working the problem from this step. And so the final answer is negative ln absolute x plus 2 plus 2 times ln absolute x minus 1 plus c.